I'm Tahshara, and my last name is pronounced Boucher, like Baba Boucher from the Waterboard. If you've ever seen it, if you have that cultural context, then you'll get it. And yes, I'll be sharing about linear search versus binary search, and I'll just hop right into it since I only have 5 minutes. Cool. So like if I was to ask you like how would you search for the word down in this crossword search, the most basic way would be like you would use the simplest way to like go down the list. So like look at you're like, oh, there's the next letter, is that an O? You're like, no. So it starts over again, and you keep going, and you'll keep going until you reach the D, and you're like, okay, that's a letter. Oh, that's a letter. W, and then you stop. You found the word down in this search, which is what linear search does. It uses the simplest way to search for a value, and it looks at every element in that array or string and checks to see if that value is met. So the function can, as I said, can accept an array or it can accept a string, and you want to loop through it and to check every like current element in that index. And you would return the index of where that value was found. If not, you would want to return -1, because in programming, -1 means that it's false, or it never was there and it wasn't found. And so this is just a quick implementation of how you would loop through it. And so we create the linear search function. And as I said, it takes in an array, or it can be a string as well. And it takes an array and it takes in a value, and then you want to do a for loop, because as I mentioned, we want to keep track of the index. And this is just a basic way, like the for each, there's different built-in methods for each language has their own built-in, but a for loop is the easiest. And so if you find that element in the index, you can just return I, if not, return that -1. And so I put 2 examples at the bottom here. And so it's like if I put in this array of strings and I'm looking for n, then it's going to return the index 2, because n is at the second index when you're following the 0 index, or starting with 0. And then again, there's an example of once you go through it and I'm searching for clown. Clown is nowhere in this array, so it's going to return -1. Okay. So then now we're going to move on to the fun stuff, which binary search, it's divide and conquer. And so actually, I feel like it skipped. Sorry, I'm having troubleshooting. I didn't discuss the the big O notation for linear search, which is the best case. So if like everything was sorted, then you would find it would be O of 1. And the worst case would be O of n, meaning that if we had 50 items in the array or in the string, then it would have to iterate 50 times to find, like, in case the item was at the last index, or if it wasn't even in the array or string at all, then you still would have to go through it 50 times. So now moving on to like binary search, which is a much faster form of searching. Rather than implementing or eliminating one element at a time, you can eliminate half of the remaining elements at a time. Because of this, like, binary search only works on sorted arrays, whereas linear search, you can use it on both sorted and non-sorted arrays. So here's like a GIF that I found. Kudos to gifimage.net, and it like goes through. So I'm gonna wait till it starts over. Sorry. So this function accepts the sorted array, and it's created. So it starts at the 47. It says like, oh no, it's not there. Then you're gonna go to the midpoint between. You're searching for 47. You start at the midpoint, and which is 14, and there it's like, oh, 14 is less than 47, so it eliminates the 0 through 14. It moves to 45, and 45 is still less than 47, so it eliminates that whole chunk. Then it goes, oh, 47 is equal to 47, so thus we found the element that we're looking for. But again, just like the linear search, it's like if the element is not found, then you're going to return -1. Again, okay, so binary search is, this is my implementation of it. And as you can see, it's just like you start with a start value, you want the endpoint, and you want the middle. And then you're going to do a while loop so that you can start at the, if like the, while the array is not equal to the middle element, which we have defined right there, and its start is less than or equal to n. And you do that because if you iterate through and you don't account for it, like if you did a for loop, then it would run over or outside of the boundaries, and that's not something that you want. And so then if the element is less than like the array at middle, then again, you're going to go to the middle element. If not, you're going to go to like this, the start becomes the middle if it's greater than, and then again, the end becomes the end still. So you're going to keep iterating through it until you find your element. And if it's not there, then you're going to return -1. And that's all. And like for me, and as Daniel noted before, I'm with Techtonica, which is a 6 months full-time hands-on project-based collaborative software engineering learning. And we have a focus on full stack JavaScript, which you can see that the implementation that I gave you all was within JavaScript. And so, yeah, that is all for my presentation.